Hi, I'm Philip Morgan, and this is my 20 by 24 vacuum easel project. Let's take a look at the materials. So these are the main constituents. Got a sheet of perforated steel, 1/32 of an inch thick, and ultimately that's going to sit atop a 2-inch thick piece of MDF, which has actually 2 1-inch or 3/4 inch, I can't remember, thick sheets that are going to be laminated together. There'll be a few other parts, but that's basically it. So the next thing I'm going to do is glue these 2 pieces of MDF together, and then I'll be back to show you the next step. Okay, the next step here is that I've marked out what are going to be some grooves in the top of the easel, of the vacuum easel. The grooves are not going to be in the perforated metal, but I've marked them on the perforated metal so I know where they're going to line up when that's glued in place. The grooves are actually going to be in the MDF. They'll be 3/8 inch wide, maybe a 1/4 inch deep. I'm going to cut them with a router in the next step. So I've transferred the marks from the perforated metal sheet through to the MDF. What you can see, what you can notice about these grooves is that they all connect. They're rectangular, they're concentric, and then right here there's going to be a groove that connects them all. And that's going to route the vacuum from the vacuum pump through to various parts of the vacuum easel. And if it works, it should give a nice even pull that draws the paper down to the surface of the vacuum easel. I've finished the next stage of the construction, which is to route channels in the surface of the MDF, which is the base of the easel. These channels are going to route vacuum from the vacuum source to the underside of the paper. So you can see that they're concentric rectangles. Each channel is 3/8 inch wide by a 1/4 inch deep, cut with a router with a square bit. Another important feature at this stage is that I've cut a slot all the way through to the other side of the easel, and that slot is going to allow vacuum pressure to go from the vacuum source into the channels. So the next step of this process is to fabricate a fitting that's going to be used to attach the vacuum source to the easel. I've completed cutting the pieces for the fitting that's going to route the vacuum from the vacuum hose into the body of the vacuum easel. It's composed of 3 pieces. This is a 3/4 inch thick piece of MDF that has a hole drilled in it. That hole will receive the vacuum hose. And then there's 2 sheets of thinner MDF. I think these might be 3/8 inch MDF. The middle piece has a channel cut into it, and the bottom piece is just a solid piece of MDF. These are going to be glued and screwed together and then placed like this on the vacuum easel. So this will carry vacuum from the hose fitting through this channel, through the slot cut in the back of the easel, to the channels on the front side of the easel. So I've got the vacuum hose fitting assembled and glued and screwed to the vacuum easel base, and I just wanted to show how that looks I've used screws to both assemble the stack of 3 pieces of wood and attach that assembled fitting to the vacuum easel base. I've used liquid nails. Okay, I've mounted the fitting for the vacuum hose to the vacuum easel, and I wanted to conduct a real quick test to test some assumptions in this project. The design for this vacuum easel is based on a smaller vacuum easel that I have that's made by Costner, which actually is right here, and you'll see the purpose of those aluminum picture frames that I have mounted to the easel in a little bit. Anyway, before I glued the perforated metal to the top of the easel, which is a one-way operation on a piece of metal that's probably 1/3 of the cost of this project, I wanted to make sure that my design for the channels that carry the vacuum to the backside of the paper was a good design. So what I've got here is a piece of cardstock that's about the same characteristics as fiber-based paper. I actually don't have a 20 by 24 piece of fiber-based paper, otherwise I would use that. So I've got it laid across the top of the easel, and you can see the fitting, sort of, there we go, that carries the vacuum from the vacuum hose, which is just a standard vacuum cleaner style, or old style vacuum cleaner vacuum hose, into the easel. So I'm going to line up the paper here. It's going to get loud as I turn on the vacuum pump. And what you'll see, maybe, if the camera's not capable of showing it really well, is you'll see some recesses appear following the grooves in the vacuum in the paper. So here we go. And you can see those kind of start to fade away. The camera's having a hard time focusing on that. But you can see them sort of fade away as the vacuum pressure diminishes. So I'd say we're in good shape for the next step, which is actually to paint the easel with Krylon Ultra Flat Black spray paint, and then glue the perforated metal to the top of to the face of the easel. And then the final step will be to attach a 20 by 24 aluminum picture frame, and I'll explain that a little bit later. The next step is to glue the perforated steel to the top of the vacuum easel. I've just finished cleaning the steel with acetone to promote a better bond, get rid of any oils from the manufacturing process. And I've partially painted the top of the vacuum easel. I haven't painted it more because I think it's going to be best to paint the perforated metal after it's glued, so that the color of the glue doesn't throw off the black color that I'm trying to achieve. In other words, it would probably have to be painted anyway after gluing it here. So I've just painted the areas where the vacuum channels are to get those nice and dark. I just wanted to stop briefly in the midst of applying the adhesive to the easel base and show you what it looks like. This stuff comes in a tube, but it has extremely high viscosity. So I just cut the tube open and have been working with some paint spackle type spreaders to spread a layer of the adhesive as evenly and thinly as I possibly can on the easel. I want it thin so that when the perforated metal goes on top of it, I don't have excess glue going up through the holes in the perforated metal and creating an uneven surface. Well, I tried. Looks like the adhesive was a little too thick in some areas, but I'm finding that 99% isopropyl alcohol and a rag and some elbow grease seems to be about all it takes to get the not yet dried adhesive that has oozed through the holes wiped away. Also, used a little nail in two areas to hold the perforated metal top in place while it dries. I'll remove those after it's dry. Quite a bit of scrubbing with isopropyl alcohol and a rag. I've got most of the adhesive that's leaked through removed. More leaks through slowly, and especially in the areas that are clamped. It may be that after this is dried I'll have to get out a sanding block and some fine paper to remove any remaining adhesive, which is fine. I wish I'd been a little more careful though to spread a really thin layer of adhesive. The next step after this dries will be to paint the entire assembly and then move on to attaching the edge hold down frame. The easel is almost finished. I've got it painted flat black with Krylon ultra flat black paint, and I've attached the edge hold down frame, which is an aluminum picture frame 20 by 24 inches that's hinged to the vacuum easel base. Fiber-based silver gelatin paper often has a problem where the edges curl away from the easel. Conventional easels use mechanical means to hold the paper flat. And with a vacuum easel, you're mostly depending on the force of the vacuum pressure to hold the paper flat, but it generally can't do that at the edge of the easel. So I asked my friend John Wimberly how he deals with this problem, and his solution is pretty ingenious, and it's what this is based on. This picture frame is just simply hinged with a length of piano hinge to the vacuum easel. And then I want to point out here on this side there's a piece of aluminum that stands about a ½ inch higher than the surface of the vacuum easel. So, and the other design feature is here there are two neodymium magnets that I've epoxied inside the frame, and those attract the frame to the steel surface of the easel. So in the darkroom, it's actually great. You just lift up the edge hold down frame, slide in a sheet of printing paper that goes against the left paper guide and then goes all the way in and stops against the rear hinge. You lower the frame, turn on the vacuum, and print. This gives you a nice, easy, repeatable way to position the paper. Keeps the edges flat and makes the whole thing a lot easier to use. Now, the last thing that I need to do, the last finishing touch for this, is to take flocking paper and apply it here all along the interior of the edge hold down frame to prevent any reflected light from reaching the printing paper. Well, now that my vacuum easel project is completed, I thought I'd reflect a little on the project and talk about what I might do differently. There are definitely most of the design I'm happy with. I liked using two 3/4 inch pieces of MDF for the base. That makes a base that's incredibly solid, which I think is a benefit in the darkroom. Anything that you're projecting an image onto, you want to stay input and be disinclined to vibrate, and this base is definitely that. It's quite heavy. I think routing the channels that carry the vacuum to the various parts of the easel worked great, and I think it's made the design a lot simpler than trying to create a sealed box, which is another design I've seen for vacuum easels. The vacuum hose fitting that I used worked quite well, and the edge hold down frame is a design that I've used on other vacuum easels, and it works quite well also. I think the only thing I would really want to change is to choose a different adhesive. The stuff that I used is made by Loctite. It's a heavy-duty construction adhesive, and it turned out just to be too viscous to work with readily. And in retrospect, I would want to use something that is a little easier to work with, maybe contact cement or something like that.